Um, so yeah, been in Chicago a long time. Like doing computer stuff, and I kind of really like the chance I get to sort of pay it forward as well. Uh, so yeah, so I think Renee has already done a presentation. Is that right? Okay, so you know a little bit about DRW. Um, it's been about almost 4 years exactly since we hired the first person out of Code Platoon. Greg Glover, still with us. Just looking at some stats from our time with Code Platoon. I think we've hired 11 so far as interns, and 10 of them have gone full time with us. 7 of them are still with us. I'd say none of them have failed. All have been successful at DRW. A few have moved on to other opportunities, but I mean that's a great result as far as I'm concerned. Just fantastic outcomes. So one of our most recent interns, still an intern right at the moment, Beck. I'm not even going to try to pronounce his last name, but he has been very successful as an intern. He's now working on I forget what the desk is, European Equity Index Options, I think, with his mentor Garrett Smith. So for me, that's a great outcome too, because of Garrett has just recently kind of gotten involved with Code Platoon as a mentor, and great things are already happening from that. So that's tells me on our side that we can do more to connect DRW folks with the program and just let Code Platoon people show what they can do.
What's Beck doing on that desk specifically?
I have no idea.
Is he building out like services for those specific traders?
It's way above my pay grade. Yeah, we see a bill come by once in a while from that desk, but yeah, I took some trading classes back in the day, but yeah, that was not enough to let me know what they're up to. But yeah, so opportunities like that can come up just by virtue of being in. He wasn't actually in our specific team, but another shared services team, and his mentor happened to be on that desk. So there's there's several places that you could land at DRW from being an intern, as I'm sure Renee's already covered.
And you're taking on one intern, or at least one this cohort, right?
Yes. As it turns out, Beck's move has left a vacancy. so yeah, there'll be a round of interviews, as I understand it, from Lima, which I may or may not be involved in it. Renee is coordinating all that, so. But I'll at least get to be with you for a couple sessions here. So I put out a link to Tom, and sorry it didn't occur to me until very recently to do that, but there is some pre-work that I had put together. Probably session 2 will be more an example or more opportunity for you to get ahead with more notice than this time around. But with Git, I came to it because the developers in my company were coming to it, and I just sort of dragged into it, kicking and screaming, and didn't really understand it, didn't appreciate it. It seemed really complicated, very magic. If any of that resonates with anybody. But after a couple of years, I finally, I'm like, you know what, this is just stupid. This is my job. I should know this stuff. So Scott Chacon, who helped found GitHub and wrote a great set of tutorials. It's git-scm.com is where you can find a lot of the stuff that he's responsible for. But he helped me dive into just the basics of Git. And that's what I'll be presenting today. It's kind of the underpinnings of what Git is all about, which is actually surprisingly simple. But it really helps you kind of know what what of all these commands and magic spells you should use and what they ought to accomplish. And probably more valuable is if they don't accomplish that, you know how to get back to where you were, so you can try again with more success. So eventually, if you have one takeaway, I think from this session, it's that Git is your friend and it has your back, and that it keeps you kind of from getting in too much trouble, which is the opposite of the first impression of Git, I know. So, so some of this too will be not only Git, but Linux. Git has very, very strong roots in Linux. Linus Torvalds, the author of Linux, wrote Git in order to manage the Linux kernel because he had a falling out with the BitKeeper folks that were originally doing that. So, so anything Windows is kind of an afterthought as far as Linus is concerned. This was originally just for Linux, but turns out a lot of people valued it enough to make it Windows friendly as well. So so that's a good thing. But that said, there's a lot of Linux commands I'll be covering today. I mean, we're on Macs, I believe, but there'll be everything that we cover today will be Linux and Mac friendly both. There'll be nothing Mac specific. But as a professional in the industry, I've known, worked with Linux or Linux predecessors since 1985, and they're still around. There's a lot of sticking power, and Git has that same kind of sticking power. So I view Git as one of the basic tools in the toolbox, and then there's a couple others too that I'll cover as well that are it just behooves you to have those and to make those your best friend and be your own best friend by having a good sound foundation in those tools. So with that, let me see if I can share some screen here and get into some of the curriculum. Which screen do I want to share? A bit too many. The one that says the essence of Git, is that it? I would like to actually share a desktop that has the stuff on it that I need. 1 second here. Actually, I'll share this desktop because I can only share one, and then I'll put stuff on it that I need. Okay, how about okay, you should see some browser window that says the essence of Git. Does that look right? Okay. Okay, so I mentioned the pre-work.
Is there any chance you can, yeah, never mind.
Is it better?
Yeah. Yes, thank you.
Is that big enough for everyone, visible? All showing up like it should? I don't know how my screen translates into Zoom visibility.
The terminal might need to be enlarged a little bit.
Okay, let me do that now before I forget.
How does that work? It looks good to me.
That good?
Yeah.
Okay. Yeah, good. We can work with that then. Okay. Yeah. So the pre-work session 1. Some of these links here are the links I referenced into the Git SCM stuff. Don't worry if you didn't cover that already. We'll dive into that. Bash is just one of those basic tools to know. There's a huge, if you do man bash, there is a huge document on bash, and you could spend a good part of your life in that document. It is very deep and detailed, and some of it's arcane. I have never been through the whole thing, I'll be honest. But bash is it's a scripting language. It's a Swiss Army knife. It's just the place you live if you're in Linux. So we'll cover some basic Linux commands that live in bash. And then Vim. I won't go into Vim here because I found it confuses the class, just because there's so many other things going on at the same time. And Vim is not a trivial subject in itself. But what I like about Vim is that it's everywhere. So Vim or Emacs, either one of those is going to be everywhere on any Linux system. Even in a very basic kind of minimal, if you find yourself in a server environment that doesn't have anything else, it will have probably Vim or Emacs. So you don't have to install anything or download macros and things like that. You can, it supports macros, but if you know Vim, you know how to get around in an editor and do some really powerful stuff without any sort of context really whatsoever as far as your environment. So that's that. I'll not talk about session 2 right now. So what we'll cover here for syllabus for session 1, 2 basic sets of things. The 3 objects are the data model for Git, and we'll go over those in some detail, along with the Linux context that they live in. And then the 3 trees, as Tom mentioned, there's some git add, git commit. You might even have done a git reset, git status, all those commands that you run in the command line, or maybe through your IDE, your Visual Studio or whatever you're using. VS Code, I think, is what is commonly used as well in Code Platoon. So they have some kind of wrappers around the Git commands, but what we're doing today is going to be those Git commands that are being wrapped. So if you understand what's going on today, you'll understand what your development environment is doing for you in Git. So the trees are what you're working with when you're doing a git diff or git add or git commit, and we'll understand those a lot better at the end of this time. So here's what we hope to accomplish here. The Git data model, as I mentioned, the just ways to kind of go back to where you were if something goes wrong, or to see what's happening if something unexpected happens. Git reset is kind of mysterious, but we'll unpack that. Then there's some terms that you see as well in using Git or reading about it. The term SHA, or content addressable file system. So these terms will make sure that we cover as well. I'm just going to keep that over here, and I made a handout here. If you go down all the way down to the bottom, there is a link for kind of what we're going to do step by step today. So you can feel free to pull that open, and if I cover something and don't explain it well enough, text. I think I'm on the Lima chat Slack channel now, so I'll try to pay attention to that. So feel free to try to get my attention there, or unmute yourself and ask a question. I'll try to leave space for questions. I do want to cover, what I'm doing with the Linux command line as well as what I'm doing with Git. So let me know if that's not coming through the way that it's supposed to. Okay, so let's start setting up. Ideally, you'll be doing a lot of typing, not just me talking. So the first thing to get a hold of is this repo that we're going to be working with. So we are right here. I'm just going to go through and do this and have you guys type along with me and pull down everything that I, do everything that I do here. And we'll start to poke around in this actual Git repo and see what, basically see how it's put together. So here I am in my home directory. So I'm not going to bother even with doing this make. I'm just going to work for my home directory. So we can just start right here, just with the git clone command. Okay, and you should see something like what I just saw here. And that will have created a learning Git directory for you. Okay, and so now we're going to start to get under the hood of Git a little bit. If you see what's in there, you see kind of, what has been checked into the directory, but you also see this .git directory. If you do an ls-la, -l means for long listing, all this extra stuff about the files that you see here. And then A means include the dot files, which normally would not be visible with an ls command. So we see that we have .git here. We see also that this D signifies at the far left that it's a directory as opposed to a file where you just have dashes. So this is a .git directory, which means we can cd into it, of course. So if we look into that, see some more files and directories. -L to see what they are, which one are which. Our goal of our investigation here is this objects directory. /objects. And you if you haven't run across this, you can usually hit tab and tab complete when you've got a file that matches the text you've already typed so far. Okay, so because we've pulled this down from GitHub, and because GitHub is efficient, it has already kind of taken this object directory and packed it up into its own format. So the next couple of commands are to kind of undo that so we can see what a Git directory would look like without having been optimized by GitHub. So that's that unpack objects.sh line. So we just type that as it is. And you can hit tab there probably to tab complete after you type a couple characters. And when I hit this, enter here, it's a script. .sh is a convention for a sh shell script, which the Bourne shell bin sh can run. Also bash can run. Any script that is a Bourne shell derivative that's on your system can run this. So it ran. slight divergence into why it ran. If you look at it, the script itself with -L. So notice over here at the far left, we see that it's a file. We also see, it's not obvious, but these are triplets of permissions over here, Linux permissions. And one of them is an X. So it's an executable script, which means that instead of saying something like, bash, /unpack, we can just say it without prefixing it with bash. And it will go ahead and try to run because of this executable bit here. So that's what was going on with that the way that bash interpreted that command. So it ran. So now that if we look at .git again in that objects directory, now we see different stuff. Scrolling up, scrolling up, scrolling up. Probably should take off the -L. Just say ls. Okay, that's a little more readable. So this is what Git does in order to store its Git objects. So that's just some setup. We'll dig into that some more in a bit. Let's do a little more setup. So let's see if I've got, yeah. So there should be another script. If we do cat, which I just did, cat is short for concatenate. If you've used Windows command line, the MS-DOS or PowerShell, there's a type command. It's the same as type. It just lists out the contents of whatever it is. Now it doesn't know whether it should or not. So if you list a binary file, it will happily go ahead and do that and probably screw up your screen. But in this case, this is a shell script. And what it is a set of aliases. So one of the built-ins that shell has is alias, which lets you just kind of basically set up your own commands. And these are a bunch of commands that are shortcuts for Git commands, as you can see here. And so we're going to put those into your environment. And I've actually written another script that does that. So this script here, append to profile. Let's cat that and see what that looks like. So a bunch of bash gobbledygook here. But the essence is that if you don't already have these in your profile, that's what this strange stuff here says. If it's not already in your profile, then go ahead and find out which shell you have. Make a profile that corresponds to your shell, has your shell's prefixed onto the profile name. Take this thing and put it at the end of, that means append here, this file, and then basically spit out to the terminal what you just did. Just an echo command of informational. So you should be able to just run that like so. And
so this would be modifying our bash profile?
It will append to the end of your bash profile, yes. Assuming you're running bash. So like base name shell, you can actually run that and see what happens. That. So base name is a bash command. And $shell is actually a special variable that tells what shell you're running. So if you echo that variable, That's what's in that variable. Base name just takes the last component of that path and uses that. So for instance, if you're running Z shell, you'll get a bin ZSH, and then you're going to get a .zsh_profile instead of a .bash profile that gets modified.
I did have one quick question regarding one was a bash profile versus a bash RC. I think one was supposed to be universal without user dependencies, and it's like kind of system wide. And then another one was only when you actually like log in with your thing. Yeah.
There's a lot of variability in mileage depending on which system you're using, whether some flavor of Linux or Mac OS, and how they handle that. But yeah, the general idea is, I think it's the profile that's the login is the convention. I have to look it up. And the idea is that sometimes you want to run a shell that doesn't do all the stuff you normally do with an interactive login shell. And so there's kind of a set of configuration you place in the .bash RC, for instance, that just does the stuff that any shell would have to do without all the interactive login stuff. And then the interactive stuff goes into the .bash profile, which itself could call the .bash RC to do the rest. But yeah, we're just going to work with the .bash profile for the purpose of this. And again, this is an example, I guess, because aliases aren't needed by any random script that would run non-interactive. But for us, we like aliases. So this will go into our bash profile. Good question. So if that all worked, you should be able to type alias and see some amount. And I've got extra stuff, I think, in my environment, but you should be able to see at least the ones that we looked at for the Git aliases. So for instance, you type ADOG, you should see something like this. And if you don't, then something went wrong. Anybody have any issues with that?
It was ADOG. What was it?
ADOG, yes.
And
if you're, I'm sorry?
I did have issues on my computer.
What was the output?
Command ADOG not found.
Okay.
Same.
I had the same thing.
Okay, so
I don't
somehow
see it as what the alias is.
Did you run source to reload the profile?
No, I didn't. Yeah,
let's see if yeah, that's right. The script does not do that for you. So yeah, so try actually source .bash profile.
That wasn't activated. That was a problem. It's working now.
Did I do it?
Actually,
yeah. You would if that hasn't been done, that may be necessary for this step. Source space tilde slash .bash profile. Let me make a note to put that in the. Pay it forward for the next class. Okay. So yes, so now you've got a really handy view into your repo, basically. ADOG is short for git space log space dash dash all space dash dash decorate space dash dash one line space dash dash graph. So you can type that instead, but I like ADOG. And then you are you're in a pager app, which is I think is less. And so with less, you could use up arrow, down arrow, to move around. You can hit space bar to move forward, and then B to move back. So this just pages through this graph of your Git repo. So very handy to kind of, as you learn how to read it, to just see where you're at and what branches you have in play, and where your head is, head in all caps. So for instance, here's where we're looking at right now. That tells me that we're on the master branch, that we are in sync with the origin, the place that we are pushing and pulling with respect to. Also tells me that there's been a lot of work on some other branch up here since, chronologically since this work happened. So
you know that's your current branch space because it says head, or what's indicating that?
yeah, head is the branch. Head points to the branch that you're currently on. So that by definition, whatever head points to is your current branch.
Thanks.
So you can also, there's also another alias called GB for get branch. That tells you as well what you're pointing to. It's, if you had more branches here, there, you'd see them, but the star would be next to the one that you're currently on. So that's all. That should be set up then. That'll be very good for us. Let's take a short detour into basic Linux and shell, and then take a short break after that. How's that sound? So this is the Linux and shell. We've covered some of this already, just by what we've done here. We've covered a couple of the LS options. A couple of others are handy. We just tack them on to the dash, like so. ls-lart. And so the T means list by time, and the R means reverse. So if you have a large directory, this will show you basically the latest files at the bottom. This isn't a great example because these are all about the same time, but so if I went to somewhere else, do the same thing, just up arrowing here. So this is kind of a better demonstration of it. Got something back from 2019, but then something as recently as June 23rd. So that comes in handy. Also, if you want to go back to the directory you're at just previously, you can do cd space dash, and that will just toggle you back to your previous directory, which is nice. You probably know about PWD for print working directory. We've used CD a lot. We've talked about cat. So grep. Anybody know what grep stands for?
Looks for the text that you specify in the stream.
Yes. Yes. And specifically get regular expression and print is what that does. So the regular expression part is another one of those basic Linux computer sciencey tools that you'll just kind of find popping up everywhere. So for instance, if we went back to the A-dog, we should be able to use a regular expression here, and sure enough, we can search for strings, and I just did slash to enter the regular expression search, and then you just type some string, You can type and then you can type, you can go back through it. Actually, never mind. I don't think that doesn't work that way in this particular context. But instead of just a string, you can also type a regular expression. So what do I mean by that? That's cool. So I'll go back up to the top, say I want to, something that would be a legitimate example here. So if I wanted to find everything that had the letter M in it, right? I could say, I could just say /M, but I could also say, what if I wanted the letter M, followed by the letter A somewhere. So that is a regular expression. That means M followed by 0 or more of anything followed by A. And these are the kind of matches we get for that. So it's a very, what's the word, arcane kind of syntax, but it's also very powerful. And so
this one
go ahead.
here, it appears to be case sensitive, because
Yes. Yes. You can make it case insensitive by tacking a /I on the end. But by default, it's case sensitive. So anyway, yeah. So regular expressions, another one to not cover today, but to kind of make a note next to because it'll come up in all kinds of contexts. Baker, we've probably seen this before. Some directory. There's a -P option I think we're going to be using, which is you can make a lot of directories at once without it complaining, so then you can so on and so forth. And then there's of course Vim, which is awesome, but I'm not going to go into that at the moment. And then there's sometimes you'll want to kind of see what's running on your computer and control it. And PS is kind of the entryway into that. So PS is for process status. You don't get much if you just type PS, but if you start adding options like -A, then you start seeing A for all, not just things. You can see what is all? Is all? Yeah, all is not just things that I own, I believe. Processes are owned by somebody. So you can add X, which means also show processes that are not attached to a terminal. So then you get a lot more. So this is all the stuff that's running on my computer right now at this instant. It's a scary amount of stuff. You can add a little bit of organization to it by doing a JF, which shows kind of a longer listing, and it shows it in a hierarchical term. So processes also have an owner and a parent. So this shows, no, that's not working very well. Actually, that's I'm confused because I'm on Mac, and that's an Ubuntu command. I'm on -EF. That's extended, so you see more. You see more information about the processes. So I might want to just see only Google processes, so I could type that into a grep command for Google. So now the output of this process is now going to be fed into grep And then grep is going to pick off everything with Google on it. So now, still a lot because Google's doing a lot of stuff. But anyway, something to explore if you want to find out how to control processes. You see the process IDs, so you can run kill with that process ID. Not that I want to do that right now. But if you own the process, you can get rid of it. Maybe it's taking up a bunch of CPU or whatever. So, okay. Time we got 12. All right. So I'll do a quick little fake at environment variables. Have you guys been over any of this? I don't want to bore you if this is not stuff that's new to you. Still good?
This is all brand new to me.
Keep going. Okay, keep going. This is really this is important. Environment variables in Bash. So if you do env, see a bunch of stuff here. This equal that basically is the format. So those are all variables that are defined in the Bash environment. Every shell has its own environment. And if I run another shell, just go bash, nothing much appears to have happened, but now I've got a shell inside of a shell. So the thing I just looked at with an env has its environment, but now this shell also has an environment. So the subshell inherits the environment of the parent shell. But I can also set more things like, I can say any, like this. So now I've got an environment variable. Actually, I don't exactly have an environment variable. I've got a shell variable. So now Frank is there. Now I'm going to get back out of this shell by I can type exit, or I can just hit Control D. And now that shell is gone. And now also Frank is gone because it only lived in the environment of that subshell. So environment variables can only go one way is the takeaway there. You can't, there's no way to get an environment variable up from a subshell into a parent shell. It just can't happen. But they do go the other way. There's some special ones. Path is one. So when you run a command like, VS code, which is not found on my machine, code is. It's probably going to kill my machine when I run it, but oh no, that is VS code. All right. So how did it find code? Because if I type which, that tells me where it lives.
It searches the current directory first, and then it searches through the paths environmental variable.
Exactly. Yeah, I'm not in that user local bin directory. I'm here, but it found it regardless. And the reason it did was because user local bin is in this special path variable right here. So path is this this search. It's a set of paths basically for searching for commands that can be run. If you'll notice, remember before we ran these commands that are the shells, like get aliases. So if I this might be a gotcha that you'd encounter sometime. If I just ran it, why did it not find get aliases now?
Because we're not in the same directory.
We are. Get aliases is right there.
Because your current directory isn't on your path, so you have to do //
Exactly. Exactly. Last time we ran /get aliases. Wait, where am I at? /get tab. So we did something like that, right? And the reason we had to have that dot was because dot is not on my path. Now I could put it on there, and you know, then it would be a viable. Now the other thing, I'm not actually sure how this happened. Oh yes, I am. We ran this, and this guy you can see is executable. Now if I try to run this, even with the dot, it doesn't run. Why is that?
Yeah, you don't have execute permissions. There's no X there.
Right, exactly. Yeah, there's, look over to the left. This is not got any X's in this set of triplets. So the way we got it to run was we ran a script that did have an X, and that script called get aliases, or no, actually just catted it. It didn't even try to run it. It could have, but in this case, it just wanted to get it into our profile. So it doesn't actually need to be executable for our purposes. We could execute it by doing this. And notice how bash, if you do this, bash will let you tab complete in this context because it's an argument. But in this context, it does not let you tab complete because it's not executable. So it's like, well, you can't run it. It's not executable. Why should I autocomplete for you? So it's pretty smart about that kind of stuff. But yeah, so the path environment variable, you could put dot on the path. It's a little risky because then anything in your current directory, wherever you're at, becomes potentially executable, which you may not want. You could easily type the wrong thing and run something you really didn't want to run. So that's one reason that dot is actually not on the path by convention, is to prevent that from happening, or at least to make it less likely to happen. We've talked about bash profile and bash RC a little bit. They are just, you know, just another bash script, except that bash itself looks for those when it runs. Okay, standard input output and error. That is a huge kind of rabbit hole, but the essence of it is that the shell has these three file handles, 0, 1, and 2. They're numbered, and when you see something like I don't know, grep blah, and you know, get aliases, right? You can look at the exit code. So it's an error. I'm a little puzzled that it didn't complain to me. Let's see if I can find an example of something that would complain. Try this. All right, so here's a shell or a Linux command called find. File name here, or look here and find a file name here. Nothing about that makes sense to find, so it throws an error. But I can do something like this. I can say, oh, I want to throw that error away. Okay, that doesn't work. And the reason is because this thing is redirecting, it's redirecting the standard output of that find command, but find is writing on the standard error. So there's in, out, and error. So if I want to really get rid of that error output, I can do something like this. And that means take the standard error and throw that away into this dev null place. That, you know, is trash, basically, trash output. So, so you'll, if you see, you know, I don't have time to explain the nuances of all this, but if you see things like that, that's what's going on. Is these commands like this are referring to the bash in, out, and error 0, 1, and 2 streams, basically. So I can also say, you know, I want to do something like this. You'll see this. You'll see this also. It'll be this, and then it'll be like at the very end, there'll be this kind of garbage that like this. That you may see, not the G, yeah, like that, right? And so what that says is take whatever the output is of this command and put it into output.log, and oh, by the way, take wherever this goes and put standard out there too. So it merges standard error and standard out into the same place. So now, you know, output.log gets whatever error and out both would have produced. So you're kind of collecting all the output and putting it into the place that you want it to go. So if you see that going on, that's what's happening here. And then of course, you know, standard input as well. If I just say cat and I want to go to this file. So what is it waiting on now? It's waiting on me, because standard input is attached to the keyboard and there's nothing coming in on the keyboard yet. So it's waiting until it gets some standard input. So I type some stuff, and then I can hit Control D to basically end of file my keyboard. And then what I typed goes out into that file. But that's an example of redirecting standard input, or actually not redirecting. It's still coming from the from my keyboard. If I wanted to redirect it, I could say let's take the output.log and go into what I typed. Is that going to work? That's going to clobber what I typed. So I could take cat and redirect what I typed, like there. Okay. So now, instead of cat waiting on the keyboard for input, it's going to take input from what I typed, and then it's going to push the output into output.log. So that's an example of redirecting the standard input. And they call it standard because there's a standard place that it comes from and goes to. So standard input, the standard is the keyboard. Standard output, the standard is the terminal. And for standard error, the standard is also the terminal. But the program kind of writes it on, you know, one of those two channels, depending on what kind of output it is, so that you have an opportunity to split it up if you want to. Just see the output but not see the error, for instance, or put the error somewhere else. So that also covers a little bit of IO redirection and pipes. So I think we used a pipe before up here somewhere. Showing an example of that. So I could say that's when you could pipe it into another command. So like here, this cat is waiting on input from me, but then what it's going to do is spit it out on standard output because I haven't given it anywhere else to go. And then that is going to feed into grep. It's going to pipe into grep. So the standard output of cat is going to the standard input of grep, and grep is going to look for success. And so grep knows, because I haven't given it a file name, that it's just going to it's going to default to looking on standard input if I don't give it a file name to go look through. So notice I just typed success once, but it came out twice because grep is writing onto the standard output. So that's happens to be the same place that I'm typing. It's a little nuanced because when I type on the keyboard, then the bash shell also echoes what I type onto the terminal. So there's some extra echoing going on there. But that's actually one reason you could use standard output and redirection to kind of confuse things. We'll hit Control D, like so, to deconfuse things. I could just do that. Now the grep output is not going to go onto the terminal along with the stuff that I type, right? Fail, fail. Okay, now grep has not echoed anything yet, right? Control D. Now, if I look at the grep output, there's only one, one line here that would have come out from grep. So anyway, just a really quick introduction, so that this is not going to teach you all about pipes, redirection, and STDIO, but if you see this thing going on, you'll at least know what's happening. And it's part of the way the bash is. It's part of the native. It's native Unix, and the way the bash handles this stuff is through these standard input-output redirection, and other Unix utilities as well do that. One last thing, then we'll take a break. If you look at something like cat is a program. If you look at something like alias is a program. Let's see, can I find something that's not? There should be some bash built-ins.
History, maybe?
Well, maybe, yeah. There we go. Type will tell me. Yeah, history. There's probably what was another one I was thinking of? ENB. No, that's hashed. Okay. So anyway, not everything is a program. Some things are bash commands. It's not always obvious which are which. Clearly, ls. I think that's it. Yeah. So you may encounter a situation where you have screwed up your path. Maybe you got rid of it. You said something like path equal, and then you tried to do ls, and suddenly it doesn't work anymore. So, but history does, and that's what's going on. Is you've gotten rid of all your references to any commands that you're familiar with, almost, but there's a few things that are just part of the bash shell that will still work. So in that case, you either have to remember what your path was, go back and reconstitute it, or you just open a new shell, and that will get your path back for you. and everything works again. Okay, let's take a break for about 10 minutes and then come back and hit the next topic.